It is given to us that ABCDE is a regular pentagon, AP bisect angle BAE and CQ bisect angle BCD. We need to find X is to Y is to Z. So in the diagram you can see the measurements X, Y and Z marked for the respective line segments. This is a very interesting sum that actually merges the concept of regular pentagons, which is basic geometry, to trigonometry. So now let us start from the pentagon basics. What is a regular pentagon? So now we know each angle of a regular pentagon is 108 degree. So let us mark it in the diagram. Because we are dealing with a regular pentagon, we know all the sides are equal. So AE is equal to AB. So we get that the triangle ABE is isosceles. Now since triangle AB is isosceles, the base angles have to be equal. So angle ABE is equal to angle AEB, which we get as 36 degree. This angle we have found out to be 36 degree. So the remaining angle here is 108 minus 36, which is a 72 degree. This is a regular pentagon. So let us take the length of each side to be U. So I have marked the measurement U in the diagram. Also, you know that the triangle ABP is a right angled triangle. Let us see what is the reason. XYZ is a random triangle which is isosceles, which means XY is equal to XZ. If XO is the angle bisector of this particular triangle, you know that if you are taking congruence of this and this part, you can say that XO also becomes the median and XO also becomes the altitude for an isosceles triangle. Therefore, for the triangle ABE, which is an isosceles triangle, AP is given to be the angle bisector, which means that AP also becomes the altitude to this particular side, thus making this angle to be 90 degree. Therefore, we have ABP to be a right angle triangle, which means I can apply trigonometric ratios to this particular triangle. When I am applying the trigonometric ratios to the triangle ABP, you can see that sin 54 is equal to PB divided by AB, which is X divided by U. Therefore, I can write the measurement X as sin 54 into U. Now, let us substitute the value of sin 54 in this particular equation. Therefore, X is equal to root 5 plus 1 by 4 into U, where U is the length of the side of the pentagon. This angle is a 72, this is a 54. So we can find out the measure of this particular angle because the sum of three angles of a triangle is a 180 degree. Here, angle BQC is equal to 54 degree, as I mentioned, by applying the sum of angles of a triangle. So here you can see that triangle BQC has become an isosceles triangle because the base angles are each equal to 54 degree. Therefore, I can say BC is equal to BQ. Now, BQ is the sum of X and Y. So, I can say that BC is equal to X plus Y. I have substituted BC as X plus Y. The measurement of BC we have taken as U. We have found out X to be root 5 plus 1 by 4 into U by using the trigonometric ratios for the right angle triangle APB. Therefore, the value of Y can be gotten as 3 minus root 5 by 4 into U. If you look at this particular diagram, you can see that AP is not only the angle bisector and the altitude. As I mentioned, this is also the median. So what does that mean? Point P divides the line segment BE into two equal parts, or you can say that BP is equal to PE. Now, BP is equal to X, PE is the sum of Y and Z. So, I can say X is equal to Y plus Z. We know the value of X and Y we can find out the value of z. After the necessary calculations, you can see that the value of z has been found out to be root 5 minus 1 by 2 into u. Now, let us take the ratio x is to y is to z, and you know that there is an unknown term u in each of these three values, which will get cancelled because we are not finding the absolute values, we are finding the ratios. We are getting the value of the ratio x is to y is to z as root 5 plus 1 is to 3 minus root 5 is to 2 into root 5 minus 1.